Hi everyone, this is the lecture for Math 222 for uh, Monday, March 23rd. Okay, let's begin with a little bit of a review of what we did last time. And what we're going to do today is we're just going to take a look at an example using the syntax that we used last time. And then at the very end of the lecture, I've got a new assignment up. It's your last assignment for this section of the course. And I'll just go over that very briefly with you, and that'll be it for today. Okay, so the first thing is let's log into our Moodle site with the usual username password. Oops. Okay, scroll down to our course. And at the very bottom here, this is the section that we were working on last time, SQL syntax for inner, left, and right joins and compound keys. And here's infection schema, data schema, sorry, infection data and infection query are the examples that we're going to go over today. And then here's your assignment 4. All right, so let me just remind you of what we did last time. So we did two things. I introduced two new syntaxes last time. The first syntax was the syntax for joins. This is the proper syntax for joins. We were doing joins before that using this poor man's technique of doing a join. And basically it's a select from where. So you have a select, list off the columns, from, list off all the tables that are part of the join, where, and then you simply state the criteria for the join as a Boolean expression. And you can use and to concatenate several Boolean expressions. Okay, so at no point here is there any obvious joining criteria or joining function or operation. And this works fine for inner joins, but it really doesn't work well for left or right joins. And so the new syntax has this form here. There's two versions of it. Select column list from the first table. This is the left table in the join. Inner join, the right table in the join. So table 1 is the left table, and table 2 is the right table in the join. And then on, and then the join criterion. And the syntax for the join criterion is identical to the syntax for the where clause, and that is it's a Boolean expression which allows you to basically state which columns must be matched between the two tables. Okay, now there is a variation on this, which is a better syntax, and that's basically this right here. And instead of using the on clause, it uses a using clause, and then it has a tuple. And over here, the tuple begins with a open round bracket and close round bracket. And inside of there, you can list off the common column name or names. So even though I have it written there in the singular, common column name, it could be several column names. And so this has advantage for two reasons. The first reason is that as long as you've named your columns correctly, and that is primary keys in one table are named the same as their corresponding secondary keys in other tables, then this syntax is nice and clean. It just basically says, okay, here's the name of the common column to use, and that's how you join. And so it's identical to, the equals between the two columns, between the columns in the two tables. But it's just, you only have to state the name once. The other advantage, and probably the bigger advantage, is that you can have several column names in here. And this is good for compound keys, which was the second syntax that I gave you last time. Okay, so like I said, we will be using this today to in an example. And what's the other syntax for keys? Well, if you take a look at this table right there, this table has a primary key, but the way the primary key is declared is by just saying primary key in the declaration for that particular column. So this basically says that student ID is the primary key for the student table. But this syntax really only works with one column. Okay, so if only one column is part of your primary key, then this will work. However, you know that when we did the normalization work, we had to sometimes take 2 or even 3 columns to become your primary key. And so how do you do that with this syntax? Well, you can't. So there's this new syntax. Now, this new syntax works with one column or more. Okay, so here is the same table as above, but now with the primary key being declared as the last line. So if you take a look at the first 3 lines, there's no obvious reason why those 3 columns aren't just ordinary columns. Okay, there's no statement about them being a primary key. But on the very last line here, you see that primary key, and then you open the round bracket, student ID, close round bracket, and that basically says that your student ID is the primary key. Okay, now that's just one column in there, but like I said, you can expand it. And so, for instance, here, if we get rid of the student ID and just use the first name and last name together as the primary key, that might be sufficient to uniquely identify every single row in this table. Well, then all you need is the first name declared, the last name column declared, and then primary key. And now you list off all the columns that are part of your primary key, and that's first, comma, last name. Okay, and there you go. You have a compound primary key. Okay, if you were to run describe on this table, under the primary key column, you would see that it lists both of those columns, both the first name and last name column are declared as primary keys. Okay, and sure enough, if you try to insert data into this which duplicates the primary key, you will get an error. So here's an example where I insert Fred Flintstone as the first and last name, and then I try to insert Fred Flintstone again, and the database server comes back and says, nope, you can't do that because Fred Flintstone is already there as a primary key for that table, and so that's not allowed. Okay, now how does this work with joins using the previous syntax? So I did this very simple example where I had 2 tables. I had a student table and a phone number table, and the primary key for the student table was first and last name. Primary key for the phone number table was just phone number. And you can see here that first and last name, both columns are in there as the secondary key corresponding to the first and last name primary key in the student table. So we actually ran this on the database, but there's the data that was inserted. But here you go. Here's where we make the join. So here we're going to join the student table and the phone number table. Those are the only 2 tables, so that's all you can really join together. All right, and I simply decided to print out the first name, last name, and phone number from the join of the student table, interjoined with the phone number table. Okay, and what do I use? Well, what's the common key? The first name, last name in the student table has to correspond to the first name, last name in the phone number table. Okay, and here it is as an inner join, but you could use either left or right. I'm picking on inner joins because they're more common, but here we go. There it is with the left join. Okay, so that's a summary of what we did last time. Let's just play with that a little bit today. And so you can see here I have infection schema, data schema, and query schema. Let's just click on that infection schema. And what is this? This is actually a database with the tables that were normalized in example 5 of the normalization sample questions. Okay, and so let's go back to that just to remind you. When we were working way back here on the entity relational design, and at some point I taught you about normalization, but because normalization is kind of a tricky subject, it's probably the most difficult subject about databases, I gave you a whole bunch of different sample questions. And so if we click over here, we had all those sample questions, and we even have the answers. I'll show you those in a second. There's example 1, there's example 2, this is example 3, this is example 4, and here's example 5. So we had this table here, and this table was not normalized at all, and so we actually had to normalize it, and it actually broke up into 3 tables. And we also had example 6, and example 6 is actually going to be your 4th assignment. Okay, so you'll be repeating what I did for example 5. You'll be repeating that for example 6. Let's just quickly look at the solution to that question for example 5. Okay, over here, if you scroll all the way down to the solution for example 5, it turns out that the table first broke 3 and F, okay, but then it also broke uh, BC and F, and so we had to split it up even more, okay, and so it turned out to be 3 tables. There was a um, actually, I have it named here infection table, but I called it patient table in my schema. We had a treatment cost table, and we also had a treatment infection table. Okay, so those are the tables, and I just noticed a misspelling there. There should be an R in there. Okay, but that misspelling is not there for the in the schema. All right, so we need those 3 tables in the schema. So let's take a look now at the schema here. And that might be a little bit small, so let me expand that. Let me just see. Can you see that? Yeah, I might clip the my image might clip the comments a little bit, but this is good enough. Okay, so this is the whoops, sorry, wrong one. This is the invoice. We want to go down here. There we go. Infection schema. I apologize. Okay, and you know what? You can't see the comment, so let me just move my image down here. Okay, so let's read that comment first. As stated, this is the database for the normalized table for the 3 normalized table in example 5. Okay, the business rules, just to remind you so that the rest makes sense, is that you have some patients with viral infections. Each viral infection has multiple treatments. Okay, but since they're expensive, you use only 1 treatment per patient. Each treatment works on only 1 infection, and the database might have lots of names, so common names may be repeated. Okay, so here we have well, first let's start here. This is very typical. When you have these databases, you're going to drop any database that already exists with that name, because after all, we're building the schema. So this is part of the development cycle. Before we put any useful information in there, it's perfectly safe to drop a database that's already there. Then we create the database called common_infection, and then we make it our default database. Okay, and here we go. We're going to create 3 tables. So we create table patient. There is a first name, last name, and birthday. I chose varchar for everything, even for the treatment. You might say, can't a birthday be a different type? It can, actually. There are date types in MySQL, but this is good enough for our purposes. We don't have to be too picky, but we have a first name, not null, last name, not null, birthday, also not null, and a treatment, not null. Okay, and for the primary key, I chose, it wasn't clear from the business rules. I said that you could have multiple names, but I figured the chances of 2 people having the same last name and the same birthday are very slim. I could have included the first name, but then literally all 4 columns would have been my primary key, which can happen. But I think the last name and your birthday is sufficient to uniquely identify any row. Okay, and then the other thing is that just because you state the last name and the birthday, a person could have actually several infections, in which case for each infection they would need a treatment, and so it turns out that you actually even need the treatment in there. Okay, as part of it. And you might say, why the treatment and not the infection? Because the treatment is actually the primary key for the infection. Okay, and the treatment is also the primary key in another table for the cost. And so over here we have a mapping between the treatment and the cost. So you have treatment and cost, and the primary key is the treatment, and you also have treatment and the infection which it treats, and the primary key again being just the treatment. Okay, and so you can see here we have a compound primary key, and then just a simple key and a simple key here, but still making use of the usual definition. Now, when we do the joins here, you might go, well, wait a sec, shouldn't we have last name and birthday also in these other tables? No, it would be sufficient to simply match the treatment from the primary key here to yeah, there to the treatment there. Okay, so in a sense, this part of the primary key there is not really acting like a primary key. The treatment is actually acting like a secondary key, even though it is part of the primary key. The true primary key is all of these. Okay, but treatment by itself is just a secondary key corresponding to the primary key in the other two tables. Okay, so it's a bit of a subtlety. We haven't seen that before, but there you go. You're seeing it in the context of this example. So we'll feed this into the database in a minute. All right, let's take a look at the data. Now, this data was identical to the data that was part of the assignment. All right, so there were quite a few patients in there, and you could see I'm making use of the abbreviated syntax, where I'm actually not giving the full list of columns before the values in the insert clause. So I just have insert into patient, and then the values, and the values have to match in order with the columns of the patient table. And so you can see here, Carrie first name, Blackburn's last name, 1963, November 14th for the birthday, and the treatment pack A, like that. Okay, and so you have quite a few patients in there. Let's take a look, because we have several John Smiths. There's John Smith there, and there's John Smith there. These two John Smiths are the same because they have the same last name, or he has the same last name. Both of these rows have the same last name and same birthday. Okay, and so poor John Smith is actually suffering with two infections at the same time. But down here we have another John Smith, but we know this is a different John Smith, because here we have Smith born in 2010, and this is Smith 1963. Okay, and so this is just to exemplify the idea that you can have collisions between names. So if all we had is for our primary key was first name, last name, that would not be sufficient. Okay, and also in this one, you could see why you need the treatment as well to be part of the primary key, because what's going on there is you can have several infections for the same person, and the infection is pointed to by the treatment, and so this treatment will actually map to an infection, and you can see that down here. ZAP corresponds to, or ZAP treats H1N3, whereas RNX3 will actually treat 2019 nCoV. Okay, so well, there you go. And then here are the rest of the data. So here we have the treatments and their costs. So pack A costs $500 and so on. And then over here we have the treatments and the infections which they treat. Okay, so great. That basically takes all the data from that example 5 and injects it into the, or we will inject it into the MySQL server. Finally, we want to ask some questions, and the questions that we're going to ask, of course, are going to be making use of the new join syntax. Okay, and I don't have a lot here, but you know, they're sufficient to show you what's going on. Okay, and I also have a slight variation of the syntax which I didn't show you earlier, and that is even when you're using the using or the on, both variations of the join syntax. You can also, in addition to that, have a where clause, and I'll show you why you might still want a where clause even on top of the using. So what queries are we going to ask? Well, the first one is, what infections does each patient have? Okay, what infection does each patient have? Well, in the patient table, you have the treatment, okay, and in the treatment infection table, you have the infection. So if you take the patient table and the treatment infection table and you join them together, you're going to get your answer. Okay, so we're going to join the patient table with the treatment infection table. Okay, and what's the common column there? It's the treatment column. Okay, so that's what's going to join them. And remember, the treatment is the primary key in this one, and it's the secondary key over there. And then you say, well, what do you want? What columns do you want as your answer? And I just decided, how about first name, last name, birthday? Again, birthday, just to disambiguate any two people, like the two John Smiths. Okay, and then the infection that they have. All right. Next, we're going to ask the question, what cost is associated with treating each patient? Okay, and this is very similar to the previous one, but this time we're going to join the patient table and the treatment cost table. And again, the common column there is the treatment table. The treatment column is the primary key in the treatment cost table, and it is a secondary key in the patient table. I know it forms part of the primary key tuple, but in this particular context, it's being used as the secondary key, which is perfectly legitimate. Okay, and then finally, we might ask the question, what infection does not John Smith have with a birthday 1963, 11/14? Okay, now this one is kind of like the first one. What infection does each patient have? But this one is not each patient, it's one particular patient. So if you take a look at the join up to here, all right, and you take a look at this join up to here, they're identical. All right, that's basically taking the two tables and joining them together as an inner join. But I don't want all the records. I only want the records for the patient who has first name John and last name Smith and has birthday 1963, November 14th. Okay, so the reason you might want a where clause in addition to the other clauses in the select using syntax is because you might want to further narrow down to a particular record, okay, within the resulting table, because whenever you join two tables, you're going to get a table as your answer, and then you might want to further search through that answer and find just one particular row within that resulting table. All right, so at this point, now we know what we're going to do. Let's actually execute this on our server. And so I'm going to switch to our shell here like that. And let's log into our server. So it's SSH minus P2222, your last name at www.freeskies.net. Okay, enter your password like that. And there we go. Okay, now let me just clear the screen so it's a little easier to see. And you can see there that I've got quite a few SQL files. The SQL files that we're going to use are infection schema. It's identical to the one we just looked at. Infection data and infection queries. Okay, let's actually use a tmux here so that we can have several shells going on. And let's go ahead and just feed the schema to the database server. Okay, so far this says, okay, run the MySQL client as user Basile and prompt me for a password, P. Okay, but if I just enter this, you know that you fall into the and enter the password afterwards. I just get into the MySQL shell, but I don't want to do that. I actually want to feed it infection schema. Okay, and ta-da! Now, this silently succeeded, and so in a minute we're going to, verify that it actually did what we wanted it to do. But the fact that it succeeded means that at least you don't have any syntax errors in there. Okay, and then the next one we're going to do is we're going to feed it the data. So the schema is there, and now we're going to populate the schema with our data. All right, and the queries are going to run them interactively because I want you to see them. I mean, I could run them from the shell. They're not formatted very nicely, and it's kind of ugly, and so we're just going to interactively work with the schema. Okay, so here I am getting into the MySQL shell, and by the way, I just did a Control L. You could see that just clears the screen, and the only reason I keep clearing the screen is just to make it easier for you guys to see what's going on. So now I can say show databases. All right, and we have quite a few there. We're going to use common infection like this. All right, and let's show tables. All right, so there are three tables. Let's make sure that the tables actually have the schema that we wanted. So describe and patient like that. And you can see there's the first name, last name, birthday, and treatment. All varchar 30s, all no nulls allowed, and the primary key is the last name, birthday, treatment. Okay, let's describe the treatment cost. And there you can see that the treatment is the treatment column is the primary key, and similarly we can do the treatment. What's the other one? Treatment infection. That's right. Okay, And so there you could see same structure as the treatment cost, but now with an infection instead of the cost. All right, so great. Let's make sure that there's actually data in them. So let's take a look at everything from the patient table. Okay, looks like it's all been populated. Let's take a look at everything from the treatment cost table. Whoops, forgot the semicolon. There we go. So you can see, what do I have there? 6 treatments and the costs associated with each one of them. And let's do the treatment infection like that. And so now you can see the various treatments and also their corresponding infections that they treat. Okay, so let me create another shell here. I just did Control B, then press C, and let's take a look at the infection queries there like that. And oh, I think things scrolled off the screen. So let me just scroll up. All right, so the first query we're going to do is that one right there. I'm just going to copy paste it. And so basically this is a join between the patient and treatment there. Okay. Join between the patient and the treatment infection. And so we want to know what infection does each patient have. Remember the table that we had above. Let me just show it to you with the data in it. Scrolling back up here. The patient table has first name, last name, birthday, and treatment, whereas the resulting table is first name, last name, birthday, and the infection. So basically each treatment maps to exactly one infection. In other words, treatment is a determinant of infection. So if you are given the treatment, you can immediately determine what the infection is from the treatment infection table. And there we go. So we know that Carrie Blackburn has 2019 nCoV. Alex Craig has H1N1. And remember, we had 2 John Smiths. Well, we had 2 John Smiths. One John Smith only has 2019 nCoV, but this poor other John Smith that was born in 2010 has both 2019 nCoV and H1N3. Okay, and so there you go. All right. Now, what was the other query we had? So we want to know now what cost is associated with each patient, and here we're going to be joining the patient table with the treatment cost table, and all we want is the first name, last name, birthday, and now the cost. Okay, so let's do that. And so you could see, there we go. So we have first name, last name, birthday, and cost instead of infection. So once again, in the original patient table, we had first name, last name, birthday, and treatment, but treatment is a determinant for cost. And so when we join the two tables together and eliminate the treatment column between the two, you could just have the patient and the cost associated with them. Okay, it's not added up in any way, but so you can see here that this John Smith that has the 2 infections will have 2 costs associated, 1 cost for each of the infections. Okay, and then finally I had that last query, which was identical to the first query, but this time I just wanted to narrow down on just the just John Smith, born in 1963. So here, select, I just want the infection because I know which patient I'm talking about. Okay, I'm talking about John Smith, born in 1963. So I just want the infection, and that infection's got to come from joining the patient and the treatment infection table. And but then don't give me all the columns, just give me that column for John Smith. 1963, and the answer is nCoV. In fact, you could see that above. So just to verify this, we can go up here. This was John Smith, born in 1963, had only 1 infection, 2019 nCoV, and there it is. All right, guys, very simple example, but at least we went through all of the stuff that all of the syntax for this particular new section of our course. Okay, let's get out of this.